Everyone, welcome back to Let's Unbound. Yes, we are continuing our AP Precalculus series, and today we are unlocking a very important early concept that you must know, which is rate of change. So, 1.2, we are into the rate of change. As usual, there will be a quick overview, and then we will solve three important problems that will help you to understand the concept in more clear way. So, let's go. And also be ready with your pen and paper. Make sure to have calculator with you, or if you have decimals, you can use that too. Here we go. Rate of change. What is rate of change? Something is changing. We are finding in which rate it's changing. It's about the measure. It will be a number that will tell us how one quantity changes relative to the other. So number means it can be positive, negative, or even zero. So rate of change formula, for example, a change from this point to this point, we represent a vertical change divided by the horizontal change. So this is which we can relate it very much with the slope formula, right? Exactly, it works in a similar way, but we are going to use different version of the formula. So rate of change is nothing but change in y by change in x. Now in calculus way, we will be using these kind of notation. Del y by del x. Del means change. Mostly for change, we will use this triangle symbol. Change in y by change in x. Change in one quantity over change in the other. So this is the rate of change part. Now we have two important rate of change. So we will be going deeper into that. Let's understand what is secant and tangent. You might be learned this in when you're dealing with circles, right? In a circle, what is a secant? What is a tangent? Same thing. For any curve, we can define a tangent and a secant. So tangent means the line which touches the curve exactly at one point. Okay, this is a curve and the line touches, the pink line touches exactly one point and it move away. So this is tangent at that point. Secant means you can see clearly it crosses 2 points, two distinct points it cuts. Okay, so this basic thing is needed. Now, average rate of change. We have two rate of change. First is average. This is what we were using whenever we need to find speed or something. This is the one, average rate of change. Usually we will work. So average rate of change is very similar to slope formula as I told you before, but it's looks something different using function notation and all. So let's see how this will work. So a curve we have, you want to find the rate of change. Okay, so curve means it's something, a behavior of function. So it goes down, right? And then goes up. So from here, that is -1 to 2, what is the rate of change? You want to analyze this. So here we have a formula, average rate of change. Can you see, you can relate it with the secant line. Average rate of change is nothing but slope of a secant line. So your endpoints are -1 and 2. So just take those points. This is your A and B. So respective, this is your f of A, that means I mean y coordinate. So f of A, and from this you will get f of B. Right? So the change in y by change in x, same concept but with different notation. So this is average rate of change. Right? So here, in this way, that will give you a number. Using that number, we will analyze different relationship. And this is an important calculus concept too. Now, instantaneous rate of change. So average rate of change, I need to tell you one more thing. So that is average rate of change is something we are working on an interval. So from time 1 to 3, you need how much speed you have covered, something like this. These will come under average rate of change. So now, instantaneous rate of change, as the name suggests, instant, at that particular instant, what is the speed of the vehicle? Something like that we will analyze. So that is instantaneous rate of change. Here only 1 point, exactly at -1 what happened, right? What is the rate of change? So to find that, again, rate of change means change in y by change in x. If you take 1 point, what can you tell about change in y? It's still 1 point only. At least 2 point here means, okay, there will be a change I can calculate. Still, we will estimate this using a formula. And you can relate instantaneous rate of change is nothing but slope of the tangent line drawn at the point. You need an instantaneous rate at -1 means plot where x is -1 on the curve and draw a tangent line. The slope of the tangent line will be the instantaneous rate of change. Okay, right. So now let's see a formula way. Instantaneous rate of change at x is equal to a number. You can relate it f of b minus f of a by b minus a we did, right? So here in place of b, you got something like a plus del x. Okay. So actually we are given 1 point, but we need some other point. So what I'm doing here is, if you zoom this line, like if you just zoom this, it doesn't make, it seems like it makes a line over here. So we can pick very, very closer points to that. Actually, mathematically, graphically, it's 1 point only the tangent touches the curve. But I'm going to estimate this. It's an approximation value. So this del x is very small value as much as possible. It can be 0.billion times of 0, 101. Or usually, easy way, we will pick 0.001 or 0.000. That much very closer point we are picking up, so that it will help me to apply the rate of change formula. Okay, instantaneous 1 point will be given, another point. For example, if 2 is given, you will pick another helping point as 2.001. Right, and you will apply here as usual in a normal way. So this is the final formula, and this will be an estimation. Right, now this is all about instantaneous and average rate of change. Let's see how we will apply this in problems. Okay, first question. A car travels 180 miles in 3 hours, then it travels another 120 miles in 2 hours. What is the average speed in the first segment? This is very, very basic question. Okay, average means we will use that slope formula, y2 minus y1. So in first segment, what is y2, what is y1? Nothing to worry about. So it's not always formula will be applicable. Normal speed formula is what? Distance over time. Total distance by time taken. Right? So it's directly given. So don't expect every time we learned a formula, so we need to focus on that whenever the rate of change is asked. No, not like that. So 180 by 3, which is 60. And unit is very important. This is meter, this is hour. So this will be meter, sorry, actually it's miles, right? So miles per hour. So 60 mph you can write. Okay. So what is the average speed in the second segment? Same thing. So in second segment, speed equal to same formula, 120 miles in 2 hours, which will give you say 60 miles per hour. So which segment has a greater rate of change? Just compare the values. Which number is greater? That is greater rate of change. So we can say neither of them is great. They are actually equal. So you can better say constant rate of change. Constantly, there is a rate of change over here. Very basic first question. I hope this is clear. Now moving to question 2. A graph shows the height of a rocket over time t. Okay, so this is h, let it be in meters, this time in seconds. Okay. Now, a graph is given, estimate the average rate of change from t equal to 1 to t equal to 3. Estimate the instant rate of change at t equal to 1.5 using the tangent line. Then you have to say which is steeper and what does it tell you. Let's see. Let's go one by one. So first question is average rate of change from t equal to 1 to 3. Rate of change I'm writing is ROC from 1 to 3. So what is the formula? Just go to the graph. Okay, actually they give secant line to us. So it's more than 30 or something. Okay, we can take 31, right? So then here, go to 3. So this goes like in between 20 and 30, not in between, a little above. So I'm approximating. So this one is 1 comma 31 and this one is 3 comma maybe 25, I think we can do. Right, so let's subtract, let's apply the formula like general slope formula. 25 minus 31. Okay, we are doing from here to here. So greater time to the lower time you should subtract. 25 minus 31 by 3 minus 1. And that's it. So do this one. 25 minus 31 is minus 16. Divided by 3 minus 1 is 2. And this would be equal to minus 8. Right? And unit, this is in meters and seconds, means rate of change means meter per second. Change in y is meter per second. So minus 8 meter per second is average rate of change. Next one, estimate the instantaneous rate of change using a tangent line. So instantaneous rate of change using a tangent line means slope of a tangent line. Is the instantaneous rate of change at that moment. Okay. So you want instantaneous rate of change here, draw a tangent, find the slope of the line. Very simple. So instantaneous rate of change. They're asking at t equal to 1.5. Okay. So at 1.5, they have already drawn the tangent to us. How will you find slope of a line? So you can use rise by run, something like that. So let me pick. So here. So let's go with this. Okay, maybe here. 1, 2. Okay, we can't do that. So let's take some decent estimate here. Maybe here to here. These also, just pick 2 points, but I'm making some easy points, reference points. That's it. So rise over run, from here, you just rise this much and run this much, right? So rise is 10 units and run is, okay, actually here horizontally, it's 0.5, 1, 0.5, like this 1.5, 2.5, like that. So 1 bar, if you cover, you're covering 0.5. So it's 10 over 1, right? So instantaneous rate of change using this rise over run concept. Rise 10, you run rightwards 1 units, not 2 units. Okay? So 10 over 1 and units meter per second. So this is instantaneous rate of change at t equal to 1.5. Okay, I hope this might be clear to you. How we calculated instantaneous and average rate of change. Right? Here we go. So third question, which is steeper and what does it tell you? Graphically, we can see it clearly, but let's see how to do. In number wise also you can compare. So which is steeper? Let's do here. So this is more, okay, this is a negative way, okay, and this is in positive way. So we have instantaneous rate of change is more steeper here, plus 10. This is something we got minus 8. So which is more steeper means, and you can better say one you have positive and negative. So instantaneous rate of change, this is steeper and it's positive. And we have to understand one more thing here. Average rate of change from 1 to 3, the height of the racket is raising, like increasing, then dropping down. So rate of change is going through many phases, right? Exactly. So throughout it's decreasing. When you look overall interval 1 to 3, it's decreasing. But exactly at 1.5, it is having it is rising fast. So if you want to interpret the result, what does this at 1.5 is steeper means the rocket is moving very fast and it's positive and kind of bigger value. So rocket is rising very fast at t equal to 2.5, sorry, 1.5. Even though overall interval, it shows a decreasing way. Average rate of change is decreasing, but it's rising. At that moment, it was rising at a very good speed. Right, so that's it. Graphical analysis of 2 important rate of change. Hope this is clear. Now, last question, an analytical solving. A cyclist position along a straight trail is modeled by the function this. S of t is negative 0.2 t cube, 2t square, where S of t is distance in miles from the starting point and t is time in hours. And we are going to analyze this for 0 to 5 hours only. Now calculate average rate of change from 1 to 4. What does this value represent? Estimate the instantaneous rate of change at t equal to 2. What does it tell you? Yeah, very similar. Again, average and instantaneous. But this time we are going to deal with equation. And C part, identify the time intervals where the function have positive rate of change and negative rate of change. So let's go one by one. First is average rate of change. From 1 to 4. So we know the basic formula. Average rate of change, I'm writing A or OC. From 1 to 4 will go like S of 4 minus S of 1 by 4 minus 1. and we need calculator help here. Just plug in 4 and this one over here. If you want, I will show you how to do this in Desmos here. So the substitution work very quick way. So just insert your function negative 0.2. There they give t. Here they just go with q plus 2. T square was given. I'm just using this. Okay. So if you want to find the values, just give a and give a slider for it. Okay. Instead x, give a. So you want s of 1, that is calculated over here, 1.8. Then if you want, note that down, and 4 you need 19.2. Very simple. So here itself we can do 19.2 minus 1.8, and this one 17.4 divided by 4 minus 1, which is 3. So finally we can evaluate everything over here in the calculator. So let me share the whiteboard. This is the way we can use Desmos. Graphing and also like normal calculation. So we got 5.8. Okay, so I'm just writing S of 4 is we got 19.2 something around, minus S of 1 is 1.8, 4 minus 1 is 3. And just solve this, we got final answer is 5.8, and unit is important. Distance is miles, a time is hours, so miles per hour. Or you can write 5.8 miles this way, slash, that also says the same thing, right? So next one, we simply apply the formula. What does this value represent? Your interpretation skill is important here. So the cyclist average speed between these two time steps is 1 to 4. This means the cyclist traveled how many miles we can calculate here. Okay, so before this you will get something 17.4 by 3. Okay, so from this we can interpret. Okay, so if what does this value represent means, we can also get from this the cyclist to travel 17.4 kilometer in 3 hours. Of course, we can find the speed and also we can say the cyclist traveled 17.4 miles in 3 hours. This is one interpretation. And also the very direct answer is also an interpretation. You can say they did the speed of the cyclist in this time stamp is 5.8. Okay, instead telling rate of change, here rate of change means speed. So you can interpret that feature. Okay, so 2 different interpretation. Now we are moving to next part B. Same thing, estimate the instantaneous rate of change at t equal to 2. What does it tell you? So instantaneous. If it graph, I will draw the tangent, I will estimate the slope of the tangent. Okay, how can I do here? So this is a cubic function. Let me imagine something like this. Okay, so we need to find a 2, you draw a tangent. But analytically, how can I do without graph? You want to estimate here. So you need to pick very closer point to the left of your number you're working and the right of the number you're working. So 2 means you pick 1.9 and 2.1. Don't take 2. Okay, we are going to estimate that, right? So, but I need 2 points to use the formula. So pick 2 closer points and then we can apply in the formula. Even you can pick 1.999 for greater accuracy, 2 point. In such a way, you can pick the zeros also, like 4 decimal places here, 4 decimal places. Okay, I'm picking this for easy stuff and apply the same average rate of change formula here. So instantaneous rate of change is approximately S of 2.1 minus S of 1.9 divided by 2.1 minus 1.9. Okay. Anyways, whatever you pick 2.01 also, then 1.99 you need to pick. Okay. So that way we will get same answer, same approximation. And again, you have to go with calculator and do this one. So S of 2.1 is 6.968 using, I'm not showing the graph again, because, calculator purpose again, because it's easy, right? Minus 5.848. 2.1 minus 1.9. Actually, we took 0.1 difference, right? That will be the one here. So just equate and solve for it. You will get 1.12 by 0.2. So try to express like denominators whole or something. So if you simplify this, you will get 5.6 miles per hour. So that exactly at the second hour, this is the speed of the cyclist, right? So this is an estimate of the, we can say speed here, we can use velocity of the cycle also, we can see, right? So, but at exact time, by taking, we estimated it by taking two nearby times. That is what it tells. And we are moving to last part. Identify the time intervals where the function have positive rate of change and negative rate of change. We are working in the interval 0 to 5. Okay. So we need to work out every interval, like average rate of change you can do. Average rate of change from 0 to 1, average rate of change from 1 to 2, average rate of 1 to 3, sorry, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. For better estimation, or you can use graphical, just graph and check that. That is also fine. So let's go in analytical way. What if it's without calculator? So here, so when t equal to, we need to find what is s of this and this, okay? So average rate of change of 0 to 1 is s of 1 minus s of 0 divided by 1 minus 0. And you need to plug in s of 1, s of 0, then 1, everything. So I will tell you the average rate of change parts here. So it will be approximately, these are already calculated. It's a repeated process. Same slope formula we are going to apply 1.8. Then you will get for this 4.2. Anyways, we are just looking upon the sign, not the exact value. And then 8.4 and 5.8. So all the rates are positive rates. So positive rate of change. If you got negative, so in that interval, it's negative. Right? So this way we can estimate the time intervals without graph. Okay, let's see what happened in the graph to have a better clarity. So I will just graph that. For graphing, you can't have A and stuff. You just go with X. So this is my graph. So 0 to 5. So X is equal to 0. Wait, what? X equals 0 and X equal 5. So in this interval, you can clearly see it's increasing wave. It's going on. It's increasing, right? So when you put your hands or fingers on this and you move right side of this, you will go up. So it's increasing. And we got the same estimation from working on the equation, right? So finally, we can say from 0 to 5, we have positive rate of change. And negative also they have asked. So you can say no interval on no interval with negative rate of change. That's it. Why? We can say some reason. No part of the function is increasing here, decreasing here, sorry. So no negative. And almost every part is having increasing behavior. This is no interval having negative, like decreasing behavior. So that's it. These are the very important skill: rate of change, what is instantaneous, and average rate of change. I hope this is clear. So yes, as usual, I have a bonus question to you. So this is, read the question and give your answer. It's very simple, basic formula application, right? So let's meet in next class, next video very soon. Until then, keep in touch with us if you like this video really. So if it helped you, you can just like and share and subscribe to us. And also if you want to join our student community, you can scan the QR code given here. That's it. Let's meet in 1.3 video very soon. Keep practicing. Stay curious.